Okay, welcome back. Nice crowd today. It's good. We have at least one. We have one presentation. Anyone else want to do a final? Okay, that's fine. That's good. So final projects aren't due until the very end. I did send out a announcement. I think. Did I? Did you get something about the final project? Because otherwise it was just contained. You had to go into the assignment itself and you could pull it up. But I put out the instructions. So now is definitely a good time to start thinking about the final project. Let me give you another sort of overview of what it is. The final project has two components. One is a presentation, 4 to 6 minutes. You can do it in class. You can make arrangements to meet me in my office if you just want to sit down and present it to me that way. The only requirement is that it has to be orally presented. You can make a video, and there's various ways to do that, some kind of video presentation, and then either upload it to me or send me the link, because sometimes the video files get big, and so if you put it on YouTube or something, just send me the link, and I can get it that way. There are some examples at the within Canvas towards the end of the Canvas modules. If you go in there, I've got previous examples for previous semesters. I'm just kind of building a little bit of a library. So oral, and then there's a written paper, which is about 2.5 to 3 pages, double spaced, and it's the same content. It's just in written form. So you're basically doing some research on how math is used in the world, in something that you have an interest of. There is no limitations. People say, well, I want to do it on this, but we didn't cover that kind of math in this class. That doesn't matter. As long as it has something to do with math. Math is numbers, counting, patterns, strategies. I had a couple guys who were coaching in a community football, a little football league, and they realized that the guys they got weren't the best athletes, but what they did is they taught them how to use triangles to open up space, and they ended up winning the tournament for the city tournament they were in. Even though they weren't, their guys weren't the best athletes, they showed them how you might not be the best, the fastest, or the biggest, or the strongest, but you use a little bit of math, hey, they were the one that got first place. That was kind of cool, so they wrote that up. That was a nice little project. So you can incorporate some project into it or something, but how do you use math in doing anything? Math of video gaming, the math of, one of my favorites was someone came and they did the math of waxing, facial waxing, and that's what she did. And she showed us that she has this chart that the shape of your face and how she does how she does your eyebrow things, how she shapes them, can determine how you look. So she can make you look like you're always mad or you're always happy. She could do it with math, with geometry. Okay, so stuff like that. Anything you do, you're just finding how somehow there's a mathematics involved. Okay, yes.
Do you need like online sources or?
No, not really. If you have them, you can kind of include them. I'm not going for APA any kind of special style. But if you find a source that you use, if you could cite it, so that we're able to look it up or attach it somehow. But the heart of it is not really to make it a research paper, but you do some research of how you use math in something you enjoy doing, hopefully, or something that you are good at, something you do. Okay, and again, just look around your world. You're using math. When you walk up the stairs, you're using math. You're calculating how, and sometimes I don't do that math very good, and that's when I trip up the stairs, right? Anyone else do that? All the time. You're just going too fast, you don't lift your foot up high enough, you trip yourself. Okay, didn't do the math right. So, and I thought of all those things because when you start doing like robotics, you have to program that into a robot. And you start realizing how much math you're actually using just naturally. Okay. So that's the idea of the goal is to tie it all in together. I think it's worth 250 points. I think the points are all in there, half and half for each. But if you just, if you meet all the requirements, at least 2 pages, 2.5, 3 pages, whatever the requirement is, 4 to 6 minutes. And the important part is include some math in there. I have some people, yes, cooking does involve math, but make it explicit. Make it explicit. Don't just say, well, here's math. I put half a cup of flour. That's math. Well, why do you put half a cup, or how do you measure the half a cup of flour? So show us how math is involved. Don't just show us how to bake a cake. It's great, but and especially if you're going to present, that's always good. That's one of my favorite. I had a dueling. I had 2 duels. One was tamales. I had 2 groups that were doing tamales, and they did it on the same night. Who made the best tamales, and they went into mathematics of making tamales. And I had another one where it was a chocolate chip cookie count. So what's the math of making a chocolate chip cookie? And I couldn't say who won, but they were both good, so that was good. So brief samples. Okay. And we have till the end. I know we're getting kind of close to, or closer at least. May 10th is basically when I would like everything turned in, either online or in person. So that's got us through finals week. May 11th is the Friday of finals week. That's when they have graduation, and we all part our separate ways and we go to different places. So it will be best if you can get everything into me by May 10th. I don't have due dates, so there's nothing there's no late penalties or anything as long as everything gets in there. You're going to see we've got, today I'm a little confused of what to do. I think we'll probably go with Chapter 3, which is linear functions. On the syllabus, I've got it backward. I've got Chapter 7 as linear functions, which it's not, and Chapter 3 is Venn diagrams, but I'm kind of going to go by what I've got in Math AS. I've got Chapter 3 next, which is linear functions. I'll also, as we go into this today, this is not on the final. None of Chapter 3 stuff, the linear stuff, is not on the final. It's actually not it's not even in the competencies. So we'll present it. Those of you who've had Math 90 here, this is the last 4 chapters of Math 90. 9, 10, 11, and 12 is all on linear functions, so it should be hopefully a good review. And if you didn't have the Math 90s, maybe you placed directly into here, probably you did well enough on the placement test that it told you you didn't need to do Math 90. Okay, so we'll go ahead and do Chapter 3, which is linear functions, because that's what comes next. And I apologize for any confusion with the syllabus. Sometimes I move things around a little bit, but we're going to, so Chapter 6, annuities and loans. We're going to go to Chapter 3, linear functions, which is Unit 9. Any questions? Let's see. We are streaming. Good. Sorry, I forgot to switch over here. Any questions about anything at this point? Good. So the goal is just to finish up these next few units. So we've got 9, 10, 11, and 12. So the last 4 units, and each of them is different. They're really not connected. You could really do them in any order you want. Some of you have already gone ahead and did the geometry. Some students find it is maybe the easiest part of the class. Other students find it the hardest part of the class. That's what this is about. It just depends on what your experience is. Unit analysis, again, it might be an easy one for you, or it might be a hard one depending upon what your experience is. But we'll go through each of them and make do. We'll try to make this interesting. But I'll be honest, it's not one of my favorite ones for this particular class, so we'll try to liven it up. But what I did is that it's made it a little more fun. Is I found for a lot of the work you're going to need to do, we're going to do something called regression. And that's why we've included this. It sort of goes with the statistics part. and I found a nice online regression calculator. So I'm going to open that up, and it's an online resource. I'm going to tuck it over here somewhere, I guess. So we'll be using this, and I'll show you how to use it. I think where should I put it? Let's just stick it there. We'll shrink it down for now. But this will do a lot of the calculations for you. So what I'm hoping you're picking up throughout this is to give you technical ways to get the math done, so that we can get to the answers and to use math to make decisions in our life. So it's about finding ways to get it done, and we have a lot of nice technology tools. So let's use them and then understand what the results that it gives us are. Okay. So again, you've got the textbook. I highly recommend opening it up. Again, if you don't read it word for word, or at least I don't, but I would at least go over. We're going to talk about functions. We're going to maybe use some function notation. So this is really very similar to what you would have gone through in your Math 90 class. Okay. But sometimes I would put it first because it might be, it's that close. So if you just came out of Math 90, we could do that first, and you would think you were still in Math 90. Yeah. But let's see what's in the PowerPoint. There we go. Okay, so, and again, this actually is not my PowerPoint, so I've used somebody else's, so it has a lot more problems. So we'll just kind of work through some of the problems, but it will also be maybe more tied in to what we're going to be doing, maybe some of them. So we'll go over a little bit of the vocabulary of what's going to go on, and see where this takes us. So we're going to talk about functions. And what is a function? What does a function do? Well, what's a relationship? Let's say a relationship. Like attached, right? They're connected somehow. You've probably had a few experiences. A parent to the children, that's a relationship that's tied. A husband and wife are legally tied together. There's a legal process, but it's also, so there's less formal types of relationships. But it's, two things are somehow put together, matched together. In a function, we have this rule that when we put those two things together, that one thing we call the input, the other gets called the output. So those are the two things we're going to put together, and it's got a rule that the input can only get matched with one output. And again, it's really wordy, but basically we put something in to the box. That's the input. Something happens to it, and in this case it'll be some kind of a math. So maybe we multiply by 3. So we put x in, some number, let's put in 5. We multiply it by 3, and what comes out the other end? 15. Okay. So there's our output. So that's kind of the visualization. Again, we try to make this not too mathy, but this is the one section that's it's a little bit more mathy than I'd like it to be. But, so I guess it's the topic on math, the math of math. Okay. So a lot of symbols that we're going to have. Take a picture. So this is the rule. Every input gets only one output. Okay. And this is where we start tying in with research. The input, usually we talk about that first, so I'll go ahead. The input will get called the independent variable because that's the part we can choose. So if you're doing research, this is the treatment group. How much of a treatment you give. So that's why it's independent. And then the output variable is what happens because of your treatment. So that's the dependent. So the output's always dependent upon what the treatment was. So this sentence is important because the function part's here in the middle. When we read this, the output comes first, the input becomes second. But when we write things with math, we write it, well, I guess we do. F of x, which is the output, equals something. We could say, just like in the last case, 3x. But we're going to see pretty soon that this, when we write something like this, the inputs also associate with the output. So this x is the input, the symbol f of x is the output. I don't like to spend too much time on definitions. Oops. Let's not go there. Let's go here. And let's just kind of keep moving forward. We done already?
Yeah.
Everything go. This is I thought I got rid of all my technical problems last week. There we go. You ever wake up and just feel like it's going to be one of those days? I felt that way today. I said, just stay in bed. Shouldn't even get out. What is, we'll just hopefully trust it here. it is.